Hi all, today we are going to discuss about the topic infrared thermometer. Analog to digital converter. There are two types of signals that carry information, analog and digital signals. Analog signals. Analog signals vary in time and the variation follow that of the non-electric signal. Digital signal. Computers can only perform processing on digitized signals. Digital signals have discrete levels and the specified value of the pulse remains. ADC Arduino project. There are four types: material and components, project circuit, working steps, and code explanation. So the first one is material and components. So the materials and components is divided into several parts, and the first one is Arduino UNO. Microcontroller is used in art and design as an open source programmable tool to create interactive works. It can drive motors, LEDs, sensors, and other components. Microcontrollers are small computing systems used for low power and low memory. AT-Mega 168 bar 328 Arduino pin mapping. Note that this chart is for the DIP package chip. The Arduino Mini is based upon a smaller physical IC package that includes two extra ADC pins. So here is the pin out diagram for Arduino UNO. So the technical specs. Microcontroller AT-Mega 328P. Operating voltage is 5 volt. Input voltage which is recommended is 7 to 12 volt, and the input voltage limit is 6 to 20 volt. Digital input output pins is 14. PWM digital input output pins is 6. Analog input pins is 6. DC current per input output pin is 20 mA. DC current for 3.3 volt pin is 50 mA. Flash memory is 32 KB, of which 0.5 KB is used by bootloader. SRAM is 2 KB and EEPROM is 1 KB, and the clock speed is 16 MHz. The second one is male-male wires and the male-female wires. So we use them to connect the components with each other. The fourth one is 20K variable resistance. We use it to control in the LCD's light. The fifth one is test board. And the sixth one is 2x16 LCD display. It shows the digital output in the project. And the seventh one is LM35 sensor. The LM35 series are precision integrated circuit temperature devices with an output voltage linearly proportional to the centigrade temperature. The LM35 device has an advantage over linear temperature sensors calibrated in Kelvin, as the user is not required to subtract a large constant voltage from the output to obtain the convenient centigrade scaling. The LM35 device does not require any external calibration or trimming to provide typical accuracies of plus or minus 1/4 degrees Celsius at room temperature and plus or minus 3/4 degrees Celsius over a full minus 55 degree to 150 degree temperature range. Lower cost is assured by trimming and calibration at the wafer level. The low output impedance, linear output, and precise inherent calibration of the LM35 device makes interfacing to readout or control circuitry especially easy. So the project circuit, diagram for project circuit is given, and the steps is encoding by using the Arduino IDE software. So the encoding is done here. The coding is given. Then the testing. The first one is testing the circuit. So the circuit is tested in this way given in the image. And the second one, the code is written, the testing code is written. So the code is given in steps with pictures. So the complete code and the final output is given here. So this is the final output.